Communication infrastructure is under increasing demands. Towers must simultaneously support new 5G bands alongside legacy cellular technologies.
They need to increase capacity for users and data and maintain the signal strength across broad networks of antennas and reduce energy usage as well.
By rethinking the switched filter banks that dot these towers, massive improvements are possible, and newer, more efficient hardware can take its place.
Well, so filters play a critical role. They ensure that the data gets transmitted and received accurately, securely, and consistently. So the switches inside make that happen. They pass the precise signal frequency to and from and even between the filters.
Switches play a vital role in defining power loss, linearity, performance across temperature, scalability and frequency, and the physical size of the equipment. Menlo Micro is fundamentally changing filter banks by replacing solid-state switches with an integrated ideal switch.
Hands down, the ideal switch simply performs better than solid-state switches. Switch linearity is much higher, by a magnitude of 100 over traditional solid-state switches. The result is a more efficient filter operation and increased bandwidth and data throughput. Power loss is significantly less, to the tune of at least 0.5 dB, and the input power of the switch can handle up to 150 watts of peak power. Each switch uses only a quarter milliwatt of power for switching, which is unprecedented, a fraction of the power levels of standard filter banks.
The innovative materials and design result in a breakthrough filter operation over the wide temperature range of -40 degrees Celsius to 85 degrees Celsius, with very little variation in insertion loss. And with very little performance variation, it can achieve more than 3 billion on-off operations over the lifetime of the filter. Designers can now relax the requirements for other components in the system. For example, a power amplifier stage could be designed for lower output levels, providing additional current and power savings for the system, and ultimately delivering better signal quality. Traditional VHF and UHF filter banks have been large with bulky machined housings, requiring multiple filters, solid-state switches, and bias and control circuitry. With the ideal switch, designers can completely change the form factor, ranging from a few inches across down to the size of a postage stamp. This miniaturized UHF tunable filter is built with the Menlo Micro 5130 ideal switch, using one switch per stage for a total of 4. Each switch connects to discrete inductors, allowing for highly selectable bandpass tuning ranges.
The ideal switch's ultra-low loss characteristics allow for greater improved on and off-state operation, which enables enhanced filter resonator performance. This enhanced resonator behavior also offers key advantages in terms of tuning and impedance matching, and which designers can leverage to simplify their filter designs.
At 3.4 by 1.6 inches, it is a 90% reduction over conventional banks. It can handle a continuous power input of up to 60 watts and can operate from -40 to over 85 degrees C. The current frequency range covers from 225 to 512 megahertz, but can be scaled down to the high frequency band and up beyond 512 megahertz to cover a wide range of frequencies for both commercial and military communications applications.
This was taken with 35 watts RF input power and highlights the excellent insertion loss across different passband frequencies. We can visually note this where the switch remains relatively cool in contrast to the surrounding inductors and capacitors of the filter.
We believe this is huge. There's no current solid-state technology that can match one-for-one the size, linearity, power loss, or performance in general across these extreme conditions. The ideal switch is poised to bring disruptive improvements across the industry.